Hi, welcome to Trigonometry. We're going to dive deep into trigonometry. Let's get started. Let's begin by learning about the Pythagorean theorem. Look at the right-angled triangle in the picture. The short side on the left is called the altitude, and the other short side on the bottom is called the base. The long side is called the hypotenuse. If you were given the altitude and the base, do you think you could calculate the length of the hypotenuse? Yes. That's exactly what the Pythagorean theorem is. The theorem states that in a right-angled triangle with sides of length a, b, and c, we always have a squared plus b squared is c squared. Look at the triangle with sides a, b, and c. We know a is the altitude and b is the base. So that would make c the hypotenuse, and we can calculate it by squaring and equating it together. The Pythagorean theorem is named after an ancient philosopher born in 570 BC named Pythagoras of Samos. Well, why is the theorem true, though? We can check that with this diagram. Looking at the diagram, we see a big outer square and an inner square. The outer square has a side length of a plus b, so its area would be a plus b squared, which is a squared plus 2ab plus b squared. The inner square has a side length c, with the area c squared. Each of the four triangles now has an area of AB divided by 2, so the blue area is 4 times this, which is 2AB. The small square and the four triangles have the same total area as a big square, so that's a squared plus b squared plus 2AB is equal to c squared plus 2AB. Canceling out the 2AB on both sides, we get a squared plus b squared is equal to c squared. Now, let's get familiar with the equation and the Pythagorean theorem. Here I have 3 different examples. Pause the video here and try to solve them without looking at the solutions. Come back and verify your answers. Welcome back. Here's the solution to the questions in the previous slide. Go through them so that you understand it. On a right triangle with an acute angle theta, as pictured, we have certain names for the various sides of the triangle. The longest side is the hypotenuse. We've already discussed this one. The angle theta is formed by 2 sides of the triangle. The hypotenuse is one of these sides. We call the other side adjacent to theta. We say the final side is opposite theta because it is literally opposite theta in the picture. The ratios of the side lengths of a right-angled triangle are called trigonometric ratios. The 3 most common and important trigonometric ratios are sine, cosine, and tangent, tan. Sine theta is opposite by hypotenuse, cosine theta is adjacent by hypotenuse, and tan theta is opposite by adjacent. Now that we know about the trigonometric ratios and its formula, let's find the values of sine theta, cosine theta, and tan theta for the diagram here. Pause and attempt it, and come back once you have your answers. Welcome back. Here's the solution. The length of the adjacent side is 7, and the length of the opposite side is 5. So, using the Pythagorean theorem, we can find out that the hypotenuse is the square root of 74. Now that we have all our sides, let's find the values of the trigonometric ratios. Sin theta is opposite by hypotenuse. We get 5 divided by the square root of 74. Similarly, cos theta is adjacent by the hypotenuse. We get 7 divided by the square root of 74. And finally, for tan theta, opposite is divided by adjacent, which gives us 5 divided by 7. Sometimes it's hard to remember the definitions of sine, cosine, and tan, so we have a useful mnemonic to help us. SLHCHTOA. The SH part reminds us that sine is the opposite divided by hypotenuse. The CAH part reminds us that cosine is adjacent divided by hypotenuse. The TOA part reminds us that tangent is opposite divided by adjacent. There's a useful relationship between sine and cosine that is a consequence of the SLHCHTOA and the Pythagorean theorem. This relationship is sine theta squared plus cosine theta squared is equal to 1. Now, let's learn why this is true. Look at the triangle on the right. We can gather 3 things from this. That sine theta is a divided by c, cosine theta is b divided by c, and that the Pythagorean theorem still stands true because it is a right-angled triangle. We can say a is sine theta multiplied by c, and that b is cosine theta multiplied by c. Let's substitute the values into the Pythagorean theorem. We get sine theta squared multiplied by c squared plus cosine theta squared multiplied by c squared. We can see that we have c squared common, canceling out c squared on both sides. We get sine theta squared plus cosine theta squared is 1. We can use trigonometry to find the unknown side lengths in a right-angled triangle. All we'll need is a little bit of algebra and the ability to calculate the sine, cosine, or tan of an angle. Sometimes we can calculate these values without a calculator, but for some, we may need to use a calculator. Now, let us try to find A and B in this triangle using trigonometry. Pause the video and try it. Welcome back. Now let's learn how to approach this. Let's start by identifying the sides of the triangle. Side B is the hypotenuse, making it the opposite side to the angle, and the other side with 7 units is the adjacent side. To find A, we should look for a trigonometric ratio that involves the opposite and adjacent side, which is tangent. Since tan is opposite divided by adjacent, we get tan of 30 degrees is divided by 7. Since tan 30 is the square root of 3 divided by 3, we can deduct that it is 7 square root of 3 divided by 3. Now, to find B, we use cos, giving us the value of B as 14 divided by the square root of 3. Our special triangles let us calculate sine, cosine, and tan values for certain angles. We can write those values down in a table. Here's that table. Do you notice anything about the rows for sine and cosine? That's right, they're the opposite of each other. Sin 30 and cosine 60 are the same. So are sine 45 and cosine 45. This happens because the angles in question are complementary. Two angles are complementary, then together they add up to 90 degrees. 30 and 60 degrees are complementary angles because 30 degrees plus 60 degrees equals 90 degrees. Similarly, 45 degrees and 45 degrees are complementary. Hence, we observed that sine of alpha is equal to cosine of alpha. Similarly, cosine of alpha is equal to sine of beta. This is only true if alpha and beta are complementary angles. Another way to think of these complementary angles is to think that if theta or x is the acute angle, then its complementary angle would be 90 minus x or 90 minus theta. So we get sine x is equal to cosine of 90 minus x, and cosine of x is sine of 90 minus x. In a right-angled triangle, if one angle is theta, the other angle would be 90 minus theta, since all angles in a triangle add up to 180. Take a look at the values of theta and its complementary angle of 90 minus x, and how we can prove that they are complementary. Now that we know how sine and cosine are related to each other, let us learn about how tan is related to it. Since sine theta is the opposite by hypotenuse, cosine theta is adjacent by the hypotenuse, and tan theta is opposite by adjacent. We can divide sine theta by cosine theta, giving us b divided by which is tan theta. So, tan theta is sine theta divided by cosine theta. In this lesson, we've come across a few formulas involving trigonometric functions that are true no matter the value of the angle theta. We call such formulas trigonometric identities. We'll collect more of these throughout the course and spend the last unit talking exclusively about them. The ones we have so far are these. You don't have to remember them now. You'll get used to remembering them as you work through the course, but write them down somewhere you can access them if needed. Why do we need to know trigonometry? We can use it to calculate multiple things like the angle of the sun using shadows, or calculate the length of a tall object we can't easily measure. How do we do that? When you see an object above you, the angle of elevation is the angle formed by the horizontal and your line of sight of the object. When you see an object below you, the angle of elevation is the angle formed by the horizontal and your line of sight of the object. Using these points of reference, we get a right-angled triangle of sorts, as pictured, to calculate the values. So far we've learned the basic trigonometric ratios. Now let's learn about reciprocal trigonometric ratios. These reciprocal ratios are sec theta, which is the reciprocal of cosine theta, cosecant theta is the reciprocal of sine theta, and cot theta is the reciprocal of tan theta. We also have complementary angles for these reciprocal trigonometric ratios. The complementary angles for all trigonometric ratios are here. Take a look at them and try to understand them. Now, look at this question and try to solve it with the table above. Try not to look at the answer. Come back and verify it once you're done. You'll notice that it's pretty straightforward since 25 and 65 are complementary angles. That's all for today. I'll see you in the next lesson.